So let's look at the combined gas law equation. We have our P1V1 over T1 equals P2V2 over T2. Um, Obviously our ones are all going to stand for our initial, so our initial pressure, initial volume, initial temperature, and our twos are our final pressure, final volume, and final temperature. Now we use this equation and we base everything off of this to get all of our other equations. Now the other equations that we can have from this, we can have in an isothermal condition, so in conditions where we have constant temperature. Okay, that means that our temperature goes away, and we have this equation. Now, this equation, we have our P1V1 equals P2V2. That's isothermal conditions, and that is accredited to the scientist Boyles. So this is Boyle's law. So we can use the combined gas law again, and we can say we have our isobaric conditions, which isobaric means that our pressure is held constant, so we can take our pressure away, and we see that we get this equation where we have V1 over T1 equals V2 over T2. Now, in that scenario, in that isobaric condition where pressure is constant, we see that we have Charles's law. And then our last one that we can see is that in our isochoric conditions where our volume is held constant, we see that we have Gay-Lussac's law, and we see that it's the P1 over T1 equals P2 over T2. And these are the three that we have to pay attention to. So we have our isobaric, isochoric, isothermal, and then we also have our combined gas law equation. Things to make sure we check out, make sure we look for when we're looking and doing these equations, make sure that the units of pressure that they match up. So whatever the pressure is initially, that unit has to be used for P2 as well. Our standard unit for volume is going to be liters. It doesn't have to be when we're using this equation, but our temperature has to be in Kelvin, so that has to be in K. Things to look out for when we're using these and solving for Boyles, Charles, and Gay-Lussac's, or using the combined gas law.